Greetings, this is Mark Anderson for Kellogg Community College, and today we're going to learn about the sum of n terms in a finite geometric series. Now, these series are going to be a small sequence, and the sequence is going to get added up, and we are going to see the formula right here. It's quite nice and convenient that what we would need to find, instead of just brute force taking all the numbers that we have and adding them up, after we do that sequence, we can actually use this formula of taking, to find the nth term. We would then first look at the first term, multiply that by 1 minus r to the nth power. That would tell us what stage we're going to, all divided by 1 minus r. So we need first our first term, in this case, that's always given to us here in this list. So this is the first term in our sequence is a sub 1 or 2. The difference between these, or the ratio, can be found by taking the previous term and dividing by the earlier term, or as said in the earlier video, a sub 2 divided by a sub 1. So the ratio in this case is also going to be 2, because 4 divided by 2 is 2, or 8 divided by 4 is 2. So to find the sum of the first 6 terms in this sequence, we will take our a sub 1, which in this case is 2, multiplied by 1 minus r, which is 2, raised to the 6th power, and then divide that by 1 minus 2. I would strongly suggest that you do these problems numerator first, then denominator. So the numerator would be then typing into any graphing calculator 2 parenthesis 1 minus 2 caret 6 in parenthesis, and you get 126 negative. And then down here 1 minus 2 is negative 1. So your answer is 126. So if we took 2, 4, 8, 16, 32, and 64, if we take those 6 numbers, we add it up to 126. Now you're probably wondering, like, why didn't we just, add up those 6 numbers? It just seems like that would be pretty quick. But you will see that in these patterns, so quickly out of the gate, the numbers get incredibly large. So in this case, we have our a sub 1 as negative 2, and our ratio in this case is going to be 4, because negative 8 divided by negative 2 is 4, and negative 32 divided by negative 8 is 4. So the ratio is 4. So to find the sum of the first 7 terms in this sequence, we will then start with our a sub 1 and go 1 minus the ratio is 4 raised to the 7th power. And then it's going to be divided by 1 minus 4. So I will do my numerator first, and if I do that, I get 32,766. Then I divide by negative 3. That would give me an answer of negative 10,922. This would be the first 7 terms in the sequence, starting with negative 2 and multiplying by 4 each time. Alright, so let's do a few more here. So this problem is going to start at negative 4. This is my a sub 1. In this case, my ratio is going to be negative 2, which is kind of fun because you'll go 8 divided by negative 2, which is 4, or negative 16 divided by 8 is negative 2. So it works out pretty nicely. Let us plug this into the equation, but we got to be very careful, because when we plug this into the equation, it's 1 minus negative 2 raised to the 5th power. Now, a note about this numerator: you cannot swipe the negatives and make this 1 plus 2 to the 5th power. And the reason why is because the 5 has to act upon the negative 2 first. Now, if any of you did that and realized you got the same answer as I did, that's because this is an odd power. But if this was an even power, then you would get the problem wrong, because you have to apply the power to the number and then do your 1 minus subtraction there. Now underneath we have 1 minus and then negative 2. So here we have the problem up on top. I will definitely compute this through and get an answer of negative 132. In the denominator, I have 1 minus minus 2, which is 3, and if I divide these two, then I would get the answer of negative 44, which makes sense since these numbers are oscillating from positive to negative to positive to negative. The sum can vary very greatly as far as we go. So that's kind of an interesting answer. Now, for our last three problems here, we're going to take a look at some very simple sigma notations, because what we're about to do is plug 1 into the value of n to find my a sub 1. And my a sub 1 in this case is 3, because 3 to the first power is 3. Now, it just so happens that this number in front also happens to be the r as well. Since there's no modifiers on the problem in front, our r and our a sub 1 are going to be the same as long as there are no modifiers in front of these equations for these sigma notations. Because this is just straight up asking what is the 8th term of a sequence that starts with 3 and then multiplies by 3 at every step of the way. So this would be, well, it seems like I kind of screwed that up there. So 3 and then 1 minus 3 raised to the 8th power, all divided by 1 minus 3. And as I've asked to, you should probably, this is the way you should do it on the calculator. Do your numerator first, which is negative 19,680, and then we're dividing by negative 2, and we get an answer of 9,840. So for our final two problems, they're going to be a little trickier because they have fractions in them. And I would strongly recommend a way to type these in, and I'm going to show you that the a sub 1 is going to be 1/4, and the r is going to be 1/4. So there's r, there's r. All right, so if we were to get to the 4th term here, this is the way that I would type it in, and it's kind of cool here. Check this out. I'm going to type in 1/4 as 1 divided by 4, and I'm going to do so as you would see this on a calculator, and then I would need a parenthesis. And then I would go 1 minus parenthesis 1 divided by 4 parenthesis caret 4. And what this is my numerator. And because these are multiplication, it doesn't matter what order you do them in. But then when you do your division, make sure you have this in parentheses. 1 minus parenthesis 1 divided by 4 parenthesis parenthesis. Now if you're able to do that, you get a decimal, and you can then turn the decimal back into a fraction using your fraction key on the calculator to 85/256. And number 11 has pretty much the same format, since our a sub 1 and r is the same thing. Our s sub 5 is going to be, as you would type it into your calculator, 2/5 multiplied by 1 minus parentheses 2/5 parentheses raised to the 5th power, closing that off, divided by parentheses 1 minus parentheses 2/5 parentheses parentheses. And you could get a decimal, which is approximately 66 hundredths, and then convert that back into a, if you didn't round the decimal, you can leave this as a perfect fraction of 2062/3125. All right, well, thank you for watching this introduction to geometric series. And these are finite geometric series, and in the next video, I'll talk about infinite geometric series.